Good morning and welcome to the Mechanical Engineering Lab. Today we will be checking the first law of thermodynamics. The first law of thermodynamics states that energy can neither be created nor destroyed. It can only be transformed from one form into the other. In today's experiment, we will be tackling the transformation of electrical power into wind power using a centrifugal fan. In addition, we'll be checking a method of running lab experiments in order to have hands-on experience on different topics that we encounter in theory. Okay, now, so let's go down to the lab. Here we are standing in front of our experimental setup. On this setup, we can run more than one experiment, but for the purpose of our experiment, we'll be only checking the efficiency of the fan. Although the system might seem complicated, nevertheless, it's a very simple and basic setup. In the red circle, we can see our centrifugal fan. This is a double suction centrifugal fan, belt driven. Belt driven means the electric driver is connected to the centrifugal fan by a belt. This fan drives air from the inlet grill, as we can see the blue arrows coming in, and it circulates the air. We can follow the yellow lines, and then it discharges through the discharge opening. So the fan will be generating flow rate across this ducting system. In the yellow circle, we can see the discharge diffuser. This diffuser can be adjustable. In other words, we can increase or decrease the amount of flow rate that can pass through. This would allow us to be able to take several points and be able to plot a curve. Now we can see the instruments that we will need to record the data. In the yellow circle, we can see the differential manometer. This would allow us to measure either the pressure at the exit point of the fan or the pressure difference between sections 7 and 8 that we will need in order to apply Bernoulli's equation and continued equation in order to find the flow rate. Now, in the pink circle, we can see the ammeter. This device allows us to measure the current consumed by the fan. The item, it's not an item, it's the tag in the green line, in the green circle. This would allow us to record the voltage that will be consumed by the fan. The voltage and the current will allow us to get the power input to the fan, and then the flow rate and the pressure will allow us to find the power output and thus the efficiency. Now we move to the sections 7 and 8. These sections have different cross-sectional area. We will be measuring static pressure at each of these areas, and knowing these areas, this would allow us to apply Bernoulli's equation and the continuity equation in order to find the velocity and thus finding the flow rate required. And now, before moving to the actual experiment, let's check the theory behind it. Efficiency is equal to output power over input power. This is always the case. Now we need to find what is the output power, what is the input power, and what are the formulas required and the parameters required in order to calculate it. For the input power, definitely in this case we have electrical input power, and it's equal to voltage times current. As for the fan output power, we need to find the flow rate and the pressure in order to calculate it. Definitely, the input power and the output power is measured in watts. And here we can see an example of calculating the fan efficiency given the different parameters. Now we'll be presenting the procedure of the experiment and then move to the experimental data for further analysis. Okay, so this is the experimental setup, and we need to follow these steps in order to be able to record the data for the experiment. So step 1 is we turn on the fan. This is the centrifugal fan, and we turn it on. Step 2 is we measure the pressure at the exit side of the fan, and we use the differential manometer in order to measure the pressure. We insert the hose for the high pressure and we record the pressure at the exit. This would allow us to find the pressure, which is the main parameter in order to calculate the power of the fan. Now, step 2 is we need to find flow rate. We will find flow rate by applying Bernoulli's equation and the continuity equation across these two sections. Similarly, we install these hoses to the differential manometer. Of course, the fan will be on, and we measure the pressure difference. Step 3, we measure the amps, the current consumption using the amp meter. And of course, we record the voltage, which is known to be 220 volts for this experiment. This would allow us to record and calculate all the data necessary to find the efficiency of this fan. This is step 1. This is the first step. Then we have the outlet, and we can vary the opening of the outlet. We vary the opening of the outlet. Flow rate across this opening will vary as well, and we repeat the same steps we have done before. As we have seen in the experimental procedure, the parameters that we needed to record are the voltage, current, pressure at the exit, and difference in pressure between section 7 and 8. The following pictures of the data recorded and of the elements. This is taken for only 1 point. We will be taking 7 points in order to be able to plot a curve. And here we can see the values of the amps, the values of the pressure at the exit of the fan, and the pressure difference between section 7 and 8. Following, we will see the table presenting all the data recorded on all different measuring points. Now, having these experimental results and knowing the formulas behind them, that is Bernoulli's equation and the continuity equation, we can calculate for flow rate. For the ease of this experiment, the flow rates have been recorded and the values are indicated in the following table. Finally, we are required to find the power input, power output, and the efficiency at these different points. Afterwards, we are required to draw the efficiency curve, compare it to standard curves, evaluate the data, discuss it, discuss possible reasons for any variation, and then draw a conclusion. And here we come to the end of the experiment. Thank you.